Welcome back. This is an Aleks study video on understanding pressure equilibrium and atmospheric pressure. So you got a picture here, two pictures of a device called a manometer, and a manometer measures pressure. So there's two types of manometers. There's an open-end manometer, which is open to the atmosphere, and then there's a closed manometer, which is only open to the vessel that has some gas in it. And the gas is exerting a pressure against some mercury metal that is free to move in the tube. So in the case of the closed tube, there's a vacuum there, and so the more atmospheres you have inside, the more it pushes, and then it pushes it up and up and up, and you'll have whatever the reading is the pressure of the gas. The open tube is the same. You've got some pressure here in the gas. It's going to shove down on the mercury and raise the mercury level, but you're also going to have air pressure that's pushing down from the atmosphere and pressing down. As soon as the two forces are balanced, the mercury stops, and then you'd be able to make a reading. Okay, so they're going to give you some information and ask you some stuff. So before we go any further, what would happen if we were in a closed tube? So this is all vacuum, okay? This is vacuum, and this is vacuum. Let's say there's no gas in there at all. What would happen to the mercury? Okay, imagine taking a loop of water hose and having some water in it, and you make a U in the hose. The water is going to be level with itself. Gravity does that. And gravity is going to attack the mercury the same way. If there's no pressure at all, if you're not considering pressure, you have to start with the idea that gravity is making these two things balanced. So in both of these cases, start with, since this is looking like it's 1.5 meters up, then this is 1.5 meters up. This is where you're going to start. The mercury will be here, then add whatever effects that you're going to have for the pressures. Okay, so start with 1.5. That'll work for you. Okay, so let's take the closed end first. In the closed tube, we don't have to add the atmospheric pressure. We're only considering the pressure inside. The only other thing that you're going to have to remember is that 1 atmosphere is equal to 760 millimeters of mercury. Okay, that's equal to 1 torr. So 1 torr is a millimeter of mercury. And so that means that if we're talking about meters here, it'd be 0.76 meters every atmosphere. So if you were to have 2 atmospheres, you start at the 1.5, the 1 atmosphere pushes it up 0.76, okay, because we're thinking in meters, not in millimeters, and then the second atmosphere would push it up another 0.76, okay? So let's see if we can do the second one first. Okay, so we've got 760 times 2. Okay, that's going to be 1,520 millimeters. So we're thinking in meters here. That's going to be 1.52 meters. So the push from inside is going to be pushing 1.52. If you remember, it's already starting at the 1.5. So that's where gravity sent it first. So we're going to have 1.5 meters plus 1.52 meters. It's 3.02. And when you do some sliding, you'll see that the answer is going to take it all the way up to, let's fill that in, all the way up to the 3. It's just barely above 3. Okay, so that would be a closed tube. Closed tube, you don't have to consider atmospheric pressure. Who cares? All right, for the open-ended tube, it's a little bit different because you're going to have atmospheric pressure pushing down. So atmospheric pressure pushes down, and the pressure from the 2 atmospheres is going to be pushing up. So remember, start at the 1.5 because that's where gravity will have it at its level, and then shove down and shove up. So the atmosphere is 1 atmosphere. So there's 1 atmosphere pushing down and 2 atmospheres pushing up. So if you were just to have a tube here, we have 1 pushing down and 2 pushing up. Okay, so the 2 cancels the 1, so it would be the same as if you had 1 atmosphere pushing up, right? If you remember, every atmosphere is going to raise it 0.76 meters. 0.76 meters. So start at the 1.5 because that's where the gravity would have it. Gravity's at 1.5. So you're going to have 1.5 plus 0.76. Okay, that's going to give you 2.26 meters. Okay. And so when you see it, when you slide the picture, what you're going to see is it's going to go to about here, and it'll stop right about there, halfway between the 2 and the 2.5. Okay, so they're going to give you all kinds of different possibilities, but this is how you do the problem.